Welcome to Math 2318, Section 1.3. In question 1, we'd like to compute the sum and difference of two vectors. They are matrices also. They have two rows by one column. So u plus v, we simply add up the individual components. So 6 and 7 is 13, 4 minus 9 is minus 5. U minus 2v, well, we just multiply 2 by each of the components in v and then perform the subtraction between the components. In question 2, we want to write this as a back as a system of equations. So this is simply x1 multiplied by each of the components, x2 by each of the components, and then when you add them back up and then match things up, you get back to the original system of equations. So not a lot to see there. All right, in question 3, we want to figure out if given matrix B here, is it possible that I can find constants so that C1A1 plus C2A2 plus C3A3 is equal to B? That's what it means to be a linear combination of A1, A2, and A3. So what that amounts to is there a solution to this particular problem? So once you write it in terms of a matrix, then I'm going to row reduce this to see, is it possible to find a C1, a C2, and C3? So when you do row reduce, we get this particular matrix. What I see is I've got a row of all zeros, which says that C3 is free. I can pick whatever I like. C2 and C1 depend upon C3. So for example, so this is our formula for generating the C1, C2, C3. So for example, if I let C3 be 0, C2 would be 1, and C1 is 2, and you can see 2 times A1 plus C2 is B here on the end, 2 minus 3, 3. All right, so yes, it is possible. It is a linear combination. In question 4, we want to determine if B is a linear combination of the vectors formed by these columns in matrix A. So is it possible to find as C1 times this first column plus C2 times the second column plus C3 times the third column so that I would end up with vector B? So I form the matrix, I row reduce it, and so what I see is I have this row of 0, 0, 0, and something not 0, which means that there is no solution. That means there is no C1, C2, C3 where that combination multiplied by the A1, A2, A3 would give me B. In question 5, we have A1, A2, and here's B. So the question is this: which value of H is B in the plane spanned by these two particular vectors? So what that means is if I form C1A1 plus C2A2, and I do this for all possible combinations of C1 and C2, if I did that, is B going to be one of those? Is it in the plane spanned by those two? All right, so I formed the corresponding matrix with columns A1, A2, and B. I tried to do row reduce, but in this situation it was of no help. It didn't give me any clear indication. So when that happens, you still have to do it by hand. So I started off with the 1 here, made 2 zeros underneath, and I begin to see some relationship how H is involved. I took row 2 and divided by 7. All right. And then I used this one to make a 0 underneath it. And so what I see is the following. I see that I've got a row of 0, 0, and minus 5 plus H. So what I want is that to be 0, because if it's not 0, then there would be no solution. So I want it to be 0, which means that H needs to be 5. And in that case, B is in the span of those two vectors. All right, question 6. We have U and V. We'd like to show that this particular vector is in the span of U and V for all possible A and Y. All right, so what they're leading you through here is, one, we would like to show it's consistent so that there is at least one solution. They form the augmented matrix with U, V, and A and Y. All right. They have taken that matrix, row reduced it, or gotten our ones and zeros, and they have this relationship about the right hand side. And so anytime I've got C1 and C2 that would be of this form, here's C1, here's C2, it is in the span. And there's nothing about this that would ever make it undefined. Therefore, C1 and C2 are defined, so it is in the span for all possible choices of A and Y.